What's going on? My name is Tosh Dalde. This is SDG Labs. Welcome to class Physics! Alright, let's say we're in the movie Gravity, right? And we got that big old backpack. In fact, let's say that backpack doesn't have any air in it, right? I'm all out of air. I'm in a lot of trouble. What I would do is I would probably take the backpack off, and then here's me, and here's the backpack. Now I got a question. On Earth, which one do you think weighs more, the person or the backpack?
The person.
The person. But the backpack's probably pretty heavy, right?
But wouldn't they have the same ratio of weight on the moon or whatever?
Well, what do you mean, the same ratio of weight? Alright, weight is equal to mass times gravity. And if you're changing gravity, yeah, I agree, your weight would change and all that kind of stuff. But in space, there is no gravity that we're talking about. So, essentially, they both don't weigh anything. NASA can make these backpacks as heavy as they want. Well, not as heavy as they want, because they still got to get it up into space. But after it's up in space, NASA can throw on these really bulky, super heavy backpacks on them because it doesn't weigh anything. Right?
Okay.
But in order to, say that here's the spaceship over here, and you want to get here, then what you would probably do, what I would do, is I would take the backpack off and throw it that way. Because in order to accelerate this backpack that has a big M, I would have to push with a force. Now if I push the backpack over here with a force, what will happen is the backpack will push in an equal opposite reaction to me pushing against it. Do you understand that equal opposite reaction thing?
Yeah.
It's kind of like if you're standing on the floor, which I'm assuming that you're doing right now, or sitting on the floor, then your weight is actually pushing down on the ground with 100 pounds. You're a pretty skinny girl, so 100 pounds. The floor is actually pushing on your feet with 100 pounds up. We call that the normal force. Because you're not accelerating. I'm assuming you're not falling right now. So this weight going down is equal to the force going up. It goes back to that sum of the forces equal to mass times acceleration. I'm assuming you're not accelerating in the y direction, so that's 0. So my W, which is going down, is equal to, or my W, negative W plus N is equal to 0. So W equals to my normal force. The weight that pushes down here is going to be pushing up here. Same thing here. The force you're pushing against the backpack is equal to the force pushing against you. And once you let it go, you're going to basically be coasting on towards the spaceship. Does that kind of make sense?
Okay.
So that's what would happen if you to get back to your spaceship. If you were to play baseball in space, the same thing happens. What I thought what I think is completely ridiculous is when they have Arnold Schwarzenegger hold a really big gun in these action movies. So big that they mount them to battleships. And, maybe not that big, but helicopters. And when they mount these big guns to these gunships and they fire them, the helicopter actually goes like this. It actually goes, say it's firing this way, it actually moves backwards. That's huge. That's a huge amount of force. So, what would happen is if Arnold Schwarzenegger actually picked up a minigun and held it with one arm and just going, in fact, he had two maybe, he's that strong. In real life, that would rip his arm off. He would just basically go boom, and then his arm would be 10 feet back. Essentially, that would, why doesn't that happen when we're firing a handgun? Well, you still feel the kickback, right? But the friction on your feet is able to provide some, resistance against being flown backwards. If you were to take a shotgun and fire it on at a roller skating rink, at a target, not at a person, and you were on ice skates, you would kind of start to slide backwards. Same thing here, is if you're playing baseball and you're a astronaut, you would throw that ball, and because of that force that you would throw it, you've applied a force pushing it that way. But that baseball has also applied an equal and opposite force pushing backwards this way. And your acceleration would obviously be very small, but you would be flying backwards when you throw the ball. Does that make sense?
Okay.
Shoots, bro. Up out.